The origins of the Vought F4U Corsair can be traced to the late 1930s when the United States Navy and Marine Corps identified a critical need for a new carrier-based fighter that could significantly outperform the current generation of naval aircraft. At the time, most fighters deployed by the U.S. Navy were slower and less maneuverable than land-based adversaries, leaving carrier task forces vulnerable in a rapidly changing aerial combat environment. In 1938, the Navy issued a requirement for a single-seat fighter capable of achieving speeds in excess of 400 miles per hour, with a climb rate and firepower to match the most advanced enemy aircraft projected for the coming decade. Chance Vought, led by Chief Engineer Rex Beisel, began developing a radical design that prioritized speed and power above all else. Central to the concept was the integration of the Pratt & Whitney R2800 Double Wasp, a massive 18-cylinder radial engine capable of producing over 2,000 horsepower, which would make the new aircraft the fastest naval fighter in the world at the time. To accommodate the engine and its equally large propeller, a 3-bladed, 13-foot Hamilton Standard unit, the team adopted a distinctive inverted gull-wing design, which allowed for shorter, sturdier landing gear while maintaining necessary ground clearance. This unique wing structure, combined with an aerodynamically clean fuselage and heavy armament of 6 50-caliber Browning machine guns, laid the foundation for what would become the F4U Corsair, a fighter engineered to dominate both the skies and the deck of a carrier. The Corsair's prototype phase began with the XF4U-1, which first took flight on May 29, 1940, marking a significant milestone in American aviation. The prototype demonstrated unprecedented performance for a carrier aircraft, reaching 404 miles per hour during tests, making it the first U.S. single-engine fighter to break the 400 mph barrier. However, the impressive speed came with a host of development challenges that threatened to derail the program. The powerful engine and long nose significantly reduced forward visibility during landing approaches, a major hazard for carrier operations. The aircraft also exhibited a tendency to bounce violently upon touchdown due to its stiff landing gear and short stroke, creating a reputation for difficult carrier landings during early testing. Stall behavior was another issue. The starboard wing often stalled before the port wing, causing unpredictable rolls near the edge of the flight envelope. Engineers worked to address these flaws through structural modifications, including redesigned landing gear struts, stall strips on the wing to balance airflow, and adjustments to the tailplane for better stability. By late 1941, despite these lingering concerns, the Corsair had proven itself fast, heavily armed, and durable enough for production, with orders placed for both the Navy and Marine Corps. The XF4U's transition into a full production model marked the beginning of the Corsair's path toward becoming one of the most feared aircraft of the Second World War. The F4U Corsair officially entered service in 1942, with its first deliveries going primarily to Marine Corps aviation units, as the Navy remained hesitant to deploy it aboard carriers due to its challenging landing characteristics. Instead, Marine squadrons based on land in the Pacific Theater became the aircraft's first operational users, putting the Corsair to the test in the brutal air battles of the Solomon Islands campaign. Pilots immediately appreciated its speed, climb rate, and devastating firepower, which allowed them to engage and defeat the agile Japanese Mitsubishi A6M0 on more favorable terms than previous U.S. fighters. The Corsair's rugged construction also enabled it to withstand substantial battle damage, a critical trait in the harsh combat conditions of the South Pacific. Early Marine squadrons quickly learned to exploit the Corsair's superior diving speed and high-altitude performance, tactics that countered the Zero's tighter turning ability. Reports from pilots highlighted the aircraft's sheer power and effectiveness as a fighter, though landing accidents and maintenance demands continued to challenge ground crews and commanders. Nevertheless, its battlefield success ensured rapid expansion of its deployment, with more squadrons receiving the aircraft by late 1942 and early 1943, cementing its place as a cornerstone of U.S. aerial strategy in the Pacific. As combat intensified, the F4U Corsair proved to be a versatile and highly adaptable platform, evolving into a multi-role workhorse beyond its initial fighter duties. In air-to-air combat, it quickly earned a reputation for superiority, with kill ratios often favoring Corsair pilots by wide margins, particularly when flown with disciplined energy tactics. The aircraft also demonstrated significant effectiveness in ground attack roles, where its speed, payload capacity, and durability made it ideal for close air support. Equipped with rockets, bombs, and later napalm tanks, Corsairs supported amphibious assaults, struck enemy shipping, and destroyed fortified positions across the Pacific Islands. By mid-1943, carrier qualification issues had largely been resolved through pilot training, mechanical refinements, and improved landing techniques, allowing the Navy to deploy the Corsair aboard fleet carriers. With both the Navy and Marine Corps operating the aircraft, it became a dominant presence over the Pacific by late 1944, contributing to U.S. air superiority and supporting every major amphibious operation from Tarawa to Okinawa. Losses did occur, often due to ground fire or accidents, but the Corsair's resilience, combined with tactical evolution, ensured its continued success even in the face of increasingly desperate Japanese defenses. Throughout its service life, the Corsair underwent numerous upgrades and spawned several variants designed to meet evolving operational demands. The original F4U-1 series was soon supplemented by improved models such as the F4U-1A, which featured a raised cockpit and a new canopy for improved visibility, addressing one of the pilot complaints from early versions. Later variants, including the F4U-1D, expanded the aircraft's ground attack capabilities, adding underwing hardpoints for bombs and rockets without sacrificing its air superiority performance. The ultimate wartime iteration, the F4U-4, introduced a more powerful R2800 18W engine with water injection, boosting top speeds and climb rates to maintain an edge against late-war adversaries. Specialized adaptations included night fighter versions fitted with radar, as well as trainer variants that help prepare new pilots for carrier operations. Production also extended beyond Vought, with Goodyear and Brewster manufacturing license-built versions to meet the massive wartime demand, resulting in over 12,000 Corsairs built by the time production ceased. Globally, the Corsair left a legacy as one of the most effective and enduring fighters of the Second World War and beyond. It was exported or supplied to several Allied nations, including Britain's Fleet Air Arm and the Royal New Zealand Air Force, where it saw extensive combat in the Pacific and Indian Oceans. Its reputation only grew in the post-war years, serving with distinction during the Korean War as both a fighter and ground attack aircraft, particularly in the hands of Marine aviators who exploited its ruggedness for close support missions. The Corsair's influence extended into aircraft design philosophy, demonstrating the value of combining raw power, structural strength, and multi-role adaptability in carrier-based fighters. By the time it was retired from frontline service in the 1950s, the Corsair had solidified its place as a cornerstone of naval aviation history, with surviving examples displayed in museums and at air shows as reminders of its pivotal role. Beyond its well-documented combat record, the Corsair also found roles in experimental and post-war contexts that underscore its adaptability. Some surplus airframes were converted for use as drones, target aircraft, and test platforms for emerging jet-age technologies, including radar and weapons trials. Others served as advanced trainers for naval aviators, preparing new generations of pilots during the early Cold War. Veteran accounts frequently note the respect the aircraft commanded, with many pilots citing its unmatched performance among propeller-driven fighters and its ability to survive missions that would have doomed lesser aircraft. Today, the Corsair remains not just a relic of its time, but a celebrated icon of military aviation, a symbol of the engineering ingenuity and tactical evolution that allowed Allied forces to achieve and maintain air dominance across multiple conflicts. The Corsair's development entered its critical testing phase with the flight of the XF4U-1 prototype, which first took to the air on May 29, 1940, and quickly established itself as a technological breakthrough for American naval aviation. It became the first U.S. single-engine fighter to surpass 400 miles per hour, achieving a recorded speed of 404 miles per hour during trials, a performance unmatched by any carrier-capable aircraft at the time. This remarkable speed was attributed to the combination of the Pratt & Whitney R2800 double WASP radial engine, generating over 2,000 horsepower, and the aerodynamic refinements introduced by Chance Vought's design team, including the distinctive inverted gull wing that reduced drag while accommodating a large propeller and shorter, sturdier landing gear. These innovations position the aircraft as a leap forward in naval fighter technology, promising to give the Navy and Marine Corps a decisive advantage in the air. Yet, the path from prototype to operational readiness was far from smooth, as numerous technical challenges emerged during the testing process. One of the most persistent issues was the Corsair's carrier handling, particularly during landings. The aircraft's long nose obstructed forward visibility during final approach, forcing pilots to adopt a curved landing pattern to keep the deck in view, a skill that required careful training and precision. The short, stiff landing gear designed to absorb carrier landings also contributed to severe bouncing tendencies on touchdown, earning the aircraft an early reputation for being unforgiving on carriers. Additionally, flight tests revealed dangerous stall behavior. The starboard wing often stalled before the port wing, causing abrupt rolling near the edge of controllability. Engineers addressed these issues through a series of refinements, including stall strips added to the wing to equalize airflow, modified tailplane geometry to improve stability, and reinforced landing gear struts to dampen impact forces more effectively. While these adjustments mitigated the worst of the problems, the Corsair's demanding flight characteristics ensured that only well-trained pilots could handle it safely during carrier operations. Despite these hurdles, the F4U-1's raw performance left little doubt about its value as a combat aircraft, and the Navy placed significant production orders even as engineers continued fine-tuning the design. By the time full-scale production began in 1941, the Corsair was already the fastest, most heavily armed naval fighter in existence, armed with 6 50-caliber Browning machine guns and capable of carrying external fuel tanks or bombs to expand its operational range and versatility. Its transition from prototype to production marked a defining moment for U.S. naval aviation, as the Navy and Marine Corps prepared to field a fighter that could finally match or exceed the capabilities of the best Axis aircraft then in service. Though the aircraft still required refinement before it would fully earn its place on carriers, its speed, power, and firepower ensured it would soon become a central figure in the Pacific Air War, where its attributes could be tested and proven under the pressures of real combat. The F4U Corsair entered operational service in 1942, with its first deliveries primarily directed to Marine Corps units rather than the U.S. Navy's carrier wings. The decision reflected lingering concerns over its challenging carrier landing characteristics, as early tests had shown that inexperienced pilots could easily damage aircraft or decks during rough touchdowns. On land bases, however, the Corsair quickly demonstrated its full combat potential, particularly in the South Pacific, where Marine squadrons began deploying it to counter Japanese air power during the Solomon Islands campaign. Its combination of speed, climb rate, and heavy armament allowed pilots to dictate engagements with the agile Mitsubishi A6M0, exploiting tactics that emphasized high-speed dives, slashing attacks, and vertical maneuvers where the Corsair's power advantage was most decisive. These tactics not only improved survivability but also led to a steadily climbing kill ratio against Japanese fighters, which had previously outmaneuvered slower American aircraft like the F-4F Wildcat. Early operational reports highlighted both the Corsair's transformative capabilities and the adjustments required to harness them effectively. Pilots praised its ability to sustain combat damage, often returning to base despite severe structural hits that would have downed lighter fighters. The rugged airframe, combined with the double Wasp engine's reliability, gave crews confidence in missions ranging from air superiority to ground attack. However, the aircraft's long nose and demanding landing behavior remained obstacles even on land. Many units had to adjust their operating procedures, including new approach patterns and extended pilot training, to reduce accident rates. Despite these difficulties, the Corsair quickly became the Marines' most prized fighter, offering them a weapon that could both seize aerial dominance and provide crucial support to ground forces in contested island campaigns. By late 1942 and early 1943, the Corsair had established itself as the backbone of Marine Corps fighter aviation in the Pacific. Squadrons flying from bases in Guadalcanal and other forward locations began integrating the aircraft into coordinated strike packages, combining air superiority patrols with bombing and strafing missions to soften Japanese positions ahead of amphibious assaults. Its speed also made it valuable for interception duties, allowing it to rapidly climb and engage incoming Japanese formations before they could reach Allied shipping or ground targets. While the Navy continued to rely primarily on the more forgiving F-6F Hellcat for carrier duty, The Corsair's battlefield results left little doubt about its strategic value, setting the stage for expanded deployment and eventual carrier integration as refinements improved its handling characteristics. Through these early combat experiences, the Corsair not only proved its design concept, but also laid the tactical foundation for its evolution into one of the most versatile and feared aircraft of the Pacific theater. As the Pacific War intensified, the F4U Corsair transitioned from a specialized land-based fighter to a versatile multi-role platform, steadily overcoming its early operational hurdles. By mid-1943, further refinements in landing gear struts, stall control devices, and pilot training had improved its carrier compatibility, allowing the U.S. Navy to begin deploying it aboard fleet carriers in larger numbers. Once carrier qualified, the Corsair rapidly became a cornerstone of naval aviation, complementing the more forgiving but slower F-6F Hellcat, and offering commanders a fighter capable of achieving air superiority while doubling as a powerful strike aircraft. Its superior speed and climb rate made it an ideal interceptor, while its ability to carry bombs, rockets, and napalm canisters turned it into a formidable ground attack and anti-ship platform, qualities that were increasingly vital as U.S. forces advanced across heavily fortified island chains toward Japan. In its air-to-air role, the Corsair established a dominant reputation, regularly achieving kill ratios that far exceeded those of earlier American fighters. Pilots learned to use its high speed and energy retention to avoid protracted turning engagements with Japanese aircraft, instead employing hit-and-run attacks, vertical maneuvers, and coordinated formations that leveraged the aircraft's power. Against the Mitsubishi A6M0 and Nakajima Ki-43, both highly maneuverable but lightly built, these tactics proved devastating. The Corsair's heavy armament, 6 50 caliber Browning machine guns with ample ammunition, delivered overwhelming firepower, often downing opponents with a single, sustained burst. By late 1944, Japanese air units increasingly relied on inexperienced pilots and obsolete aircraft, further amplifying the Corsair's effectiveness in aerial combat. Beyond its fighter duties, the Corsair became an essential tool for ground support operations. Its robust construction allowed it to sustain low-level runs through heavy flak, and its payload capacity made it a flexible strike aircraft. Corsair squadrons regularly launched attacks on enemy airfields, shipping, and entrenched positions, delivering rockets, bombs, and strafing runs in support of amphibious assaults from Tarawa to Saipan, and later Iwo Jima and Okinawa. The aircraft's resilience enabled it to return from missions with severe damage, a trait that earned it the trust of pilots who often operated at low altitude under heavy fire. While losses were inevitable, particularly to ground-based defenses, the Corsair's ability to fulfill multiple roles simultaneously made it invaluable to the fast-paced, amphibious style of warfare that defined the latter Pacific campaigns. By the war's final year, the Corsair had become one of the most important assets in the U.S. arsenal, flying from both land bases and carriers as the Allies pressed closer to Japan. Its versatility allowed commanders to streamline air operations using the same squadrons for interception, escort, and strike missions rather than dispersing tasks across multiple aircraft types. This operational flexibility, combined with its technical performance, positioned the Corsair as not only a war winner but also a model for the next generation of carrier-based aircraft, which would need to combine speed, firepower, and durability to meet the challenges of post-war conflicts. Its combat record during this period cemented its status as one of the most successful fighters of the Second World War, a machine equally adept at dominating the skies and delivering decisive blows against targets on land and sea. The F4U Corsair's evolution throughout its production run reflected continuous efforts to refine its performance, versatility, and survivability as the demands of combat shifted. The original F4U-1 model, while groundbreaking in speed and power, retained the long nose and birdcage canopy that hindered forward visibility, particularly during carrier landings. This limitation was addressed with the F4U-1A, which introduced a raised pilot seat and a semi-bubble canopy, significantly improving pilot sightlines. This variant also received strengthened landing gear, stall strips, and revised approach techniques, making carrier operations safer and more reliable. These changes marked a turning point, allowing the Corsair to transition fully from a land-based asset for the Marines to a core component of U.S. Navy carrier air wings. As combat requirements diversified, so did the Corsair's configurations. The F4U-1D became the primary strike variant, fitted with additional underwing pylons capable of carrying bombs and rockets alongside its 6 50-caliber machine guns. This adaptation turned the Corsair into an effective fighter-bomber, capable of close air support and interdiction missions without sacrificing its air superiority capabilities. Specialized variants also emerged, including the F4U-2 Night Fighter, which integrated radar systems and flame dampeners to hunt enemy aircraft under cover of darkness. Later versions like the F4U-4 pushed the design to its peak wartime performance, incorporating the more powerful Pratt & Whitney R2800 18W engine with water injection, which boosted top speed to over 446 miles per hour, and improved climb rates, allowing it to remain competitive even against late-war adversaries. These upgrades ensured the Corsair's continued relevance as newer enemy aircraft entered service, and as missions expanded beyond traditional dogfighting. The scale of production required to sustain the Corsair's deployment led to significant industrial expansion. Chance Vought alone could not meet wartime demand, prompting license production by Goodyear, whose versions carried the FG designation, and Brewster, whose aircraft were marked as F3A. Though Brewster-built examples were often criticized for quality issues, Goodyear's production ensured that enough aircraft reached frontline units to support simultaneous operations across the Pacific. By the end of the war, over 12,500 Corsairs had been built, making it one of the most produced American fighters of the era. Internationally, the Corsair's adaptability made it attractive to allied nations. The British Fleet Air Arm became an early operator, modifying its tactics to handle the aircraft's landing challenges on smaller carriers by introducing curved approach techniques that were later adopted by U.S. pilots. British Corsairs participated in both European and Pacific operations, including strikes against the Tirpitz in Norway and attacks on Japanese positions in Southeast Asia. The Royal New Zealand Air Force also flew Corsairs extensively, using them in support of ground operations and maritime patrols. These foreign deployments not only extended the aircraft's reach, but also contributed to its refinement, as operational feedback from different theaters influenced subsequent upgrades. By the time production ceased, the Corsair had evolved into a highly adaptable, multi-role platform that embodied the shift in naval aviation toward fighters capable of dominating the air while also delivering significant firepower against ground and sea targets. Its iterative improvements, spanning visibility enhancements, engine power, armament, and specialized mission equipment, ensured that it remained at the forefront of carrier-based combat aviation throughout the Second World War, and positioned it to remain a valuable asset in the early post-war years, even as jet propulsion began to redefine aerial warfare. The F4U Corsair's global impact and enduring legacy stem from both its extensive operational career and its influence on future aviation doctrine. By the end of World War II, the Corsair had established itself as one of the most effective and versatile combat aircraft of its generation, serving not only as a frontline fighter but also as a strike and support platform across multiple theaters. Beyond U.S. Navy and Marine Corps service, it became a critical asset for Allied air forces, particularly the British Fleet Air Arm and the Royal New Zealand Air Force, both of which adapted the aircraft for their own operational needs. British carriers, often smaller and more challenging for landings, developed specialized approach techniques that later became standard across carrier aviation, proving that the Corsair could operate reliably from decks once considered unsuitable for such a powerful aircraft. This adaptability solidified its reputation as a global workhorse rather than a design limited to American doctrine. After the war, the Corsair's story continued as it found new life in the Korean War, where it played a vital role in close air support, interdiction, and even occasional air-to-air engagements. Though jet fighters like the F-86 Sabre had begun to dominate air superiority missions, the Corsair's ability to loiter over battlefields, carry heavy ordnance loads, and absorb punishment made it indispensable for ground attack missions, particularly in the rugged terrain of the Korean Peninsula. Marine aviators, many of whom had flown the type during World War II, leveraged its durability and payload to deliver precision strikes against North Korean and Chinese forces, cementing its value as a reliable combat platform even in an era of rapid technological change. The aircraft's combat effectiveness in Korea extended its operational relevance well into the early 1950s, demonstrating that piston-powered fighters still had a place in modern conflicts when properly employed. The Corsair also saw post-war service with numerous foreign air forces, extending its operational legacy worldwide. France operated the aircraft during conflicts in Indochina and Algeria, employing it in both ground attack and maritime strike roles. Other nations, including Argentina, El Salvador, and Honduras, utilized the Corsair in limited combat roles, with some aircraft remaining in service into the 1960s and 1970s. The type's longevity, especially in developing nations, highlighted its ruggedness, ease of maintenance, and suitability for roles where speed and altitude were less critical than reliability and firepower. Culturally, the Corsair became an enduring icon of naval aviation, remembered as a symbol of Allied air superiority and industrial capability during World War II. Its distinctive inverted gull wing and reputation for unmatched performance among propeller-driven fighters gave it a lasting place in aviation history. Surviving examples, meticulously restored, now appear in museums, air shows, and private collections around the world, where they serve as living reminders of an aircraft that defined an era. These aircraft not only showcase the Corsair's technical achievements, but also highlight its broader historical role as a bridge between the propeller-driven fighters of World War II and the jet-powered combat aircraft that would dominate the skies in subsequent decades. For aviation historians, the Corsair's legacy is also one of influence. Its design philosophy, combining immense engine power, structural toughness, and multi-role capability, shaped post-war fighter development, particularly for naval aviation. It demonstrated that a carrier-based aircraft could deliver performance equal to or exceeding land-based fighters, challenging long-standing assumptions and setting the stage for the jet-powered naval fighters of the 1950s and 1960s. Though its era as a frontline combatant eventually ended, the F4U Corsair remains a benchmark for how a single aircraft can redefine the expectations and capabilities of naval air power, leaving a legacy that endures both in the annals of history and in the skies wherever surviving examples still fly today. Beyond its celebrated combat history, the F4U Corsair's lesser-known roles and post-war adaptations further illustrate its importance as a flexible and enduring platform. After its primary service life in frontline combat, many Corsairs were converted for experimental and auxiliary purposes, helping to advance aviation technology and training during the transitional years between piston and jet propulsion. Several surplus airframes became target drones, modified with remote control systems to serve as live maneuvering targets for anti-aircraft gunnery and missile testing. These drones allowed U.S. forces to evaluate new weapon systems under realistic conditions, extending the Corsair's utility long after its combat peak. Others were adapted into testbeds for experimental equipment, including radar systems, weapons trials, and early jet assist takeoff technology, roles that kept the aircraft relevant within research and development programs through the late 1940s and early 1950s. The Corsair also found a continued role in advanced flight training, particularly for naval aviators transitioning to more complex aircraft or preparing for carrier qualification. Its powerful engine, high performance, and demanding handling characteristics made it an ideal platform for teaching advanced skills, ensuring that pilots were well prepared for the increasing speeds and technical challenges of the emerging jet age. Many aviators credited their time in the Corsair with developing the precision and discipline needed to master newer aircraft, solidifying its reputation not only as a combat tool but as a teaching instrument. Veteran accounts consistently emphasized the respect the Corsair commanded, even in these secondary roles. Pilots frequently noted its durability and performance, qualities that allowed it to perform missions far beyond those originally envisioned by its designers. In foreign service, particularly with nations such as Honduras and El Salvador, Corsairs even saw combat as late as the 1969 Football War, where they engaged in what became some of the last recorded piston-engine dogfights in history. These late uses, though far removed from the massive battles of the Second World War, underscored the aircraft's longevity and effectiveness, even decades after its first flight. Today, the Corsair stands as both a historical artifact and a living presence, with restored examples flying at air shows worldwide. These aircraft serve not only as a tribute to their wartime contributions, but also as a link to the engineering achievements of the 1940s, when designers pushed the boundaries of piston engine performance. In museums, static displays highlight its distinctive inverted gull wing, powerful radial engine, and versatility across missions, ensuring that new generations understand its role as a cornerstone of naval aviation history. While jet-powered aircraft ultimately surpassed it in speed and capability, the Corsair's record of adaptation, innovation, and longevity has cemented it as one of the most iconic and influential fighters of the 20th century, remembered not just for its victories in war, but for its enduring service across decades of aviation progress. While the F4U Corsair's fame is rooted in its dominance during the Second World War and its combat service in Korea, its broader legacy lies in how it bridged two eras of military aviation and influenced the path of carrier-based aircraft development. Introduced in 1942 as a piston-engine powerhouse, it became the first carrier-capable fighter to exceed 400 miles per hour, setting a performance standard that forced other naval air arms to reconsider the role of speed, range, and payload in future designs. Its ability to deliver fighter-level air superiority while performing heavy strike duties foreshadowed the multi-role philosophy that would become a hallmark of post-war jet fighters. Engineers and tacticians alike studied the Corsair's balance of raw engine power, structural resilience, and adaptability, traits that were later incorporated into early jet aircraft intended for carrier service, such as the McDonnell F-H Phantom and Grumman F-9F Panther. The Corsair also redefined operational doctrine for naval aviation. Before its introduction, carrier-based fighters were generally viewed as defensive tools, tasked with intercepting attackers rather than leading offensive operations. The Corsair's range, speed, and payload capacity changed this perception, allowing carrier groups to project force deep into enemy territory without relying solely on dedicated bombers. It demonstrated that a single aircraft type, when properly designed, could fulfill multiple roles: escort, interception, and strike, simplifying logistics and increasing the striking power of carrier task forces. This shift, proven in the Pacific and later reinforced during its ground attack missions in Korea, directly shaped post-war planning for aircraft that could dominate all mission profiles from a single platform. Internationally, the Corsair's enduring presence also influenced smaller air forces that lacked the resources to rapidly transition to jets. Countries operating the Corsair after World War II, from France to various Latin American nations, developed doctrines around maximizing the capabilities of a rugged, versatile fighter-bomber, rather than focusing solely on technological parity with the superpowers. Its performance in conflicts such as France's colonial wars and the brief but notable 1969 football war between El Salvador and Honduras, where Corsairs engaged in some of the last recorded piston-engine dogfights, underscored the aircraft's ability to remain relevant despite being technologically surpassed. For the pilots who flew it, the Corsair often symbolized a rite of passage, particularly because of its demanding flight characteristics. Mastering the aircraft required skill and discipline, traits that carried over as many aviators transitioned into the jet age. Its operational quirks, from the curved carrier landing approach to its torque-heavy takeoffs, became benchmarks for training and professionalism in naval aviation. The lessons learned from operating and refining the Corsair, both in engineering and in tactics, continued to resonate within military aviation long after its final retirement. Today, the Corsair endures as more than just a relic of a bygone era. Airworthy examples at air shows showcase its speed, distinctive silhouette, and roar of the double Wasp engine, offering tangible connections to the generation of aircraft that bridged the leap from early, modestly powered carrier planes to the complex, multi-role jets that would dominate the skies by the 1950s. Its impact, measured not just in combat records but in the doctrines and designs it inspired, ensures that the Corsair remains a pivotal chapter in the evolution of naval aviation, a machine that did not simply fight wars but helped define how wars in the air would be fought for decades to come. The F4U Corsair's story also illustrates how a single aircraft type could influence global aviation trends and maintain operational value long after its peak production years. While most American and British squadrons transitioned to jet fighters by the early 1950s, the Corsair's durability, simplicity of maintenance, and ability to deliver heavy ordnance allowed it to remain in active military service across the world for decades. Nations with smaller defense budgets or those engaged in localized conflicts relied on the Corsair as a cost-effective alternative to more advanced aircraft, using it as both a strike platform and, when necessary, a frontline fighter. In Latin America particularly, the Corsair became a centerpiece of air forces in countries like Honduras and El Salvador, where it was used not only for patrol and training but also in combat. culminating in the 1969 Football War. In this brief but intense conflict, Corsairs from both nations engaged in the last known air-to-air battles between piston-engine fighters, a rare echo of World War II aerial tactics nearly 3 decades after the aircraft's introduction. These late uses highlight the Corsair's resilience and adaptability, traits that extended its operational life far beyond that of most of its contemporaries. While it could no longer compete with jet fighters in speed or altitude, its rugged construction, long range, and payload capacity made it ideal for ground attack and maritime patrol duties in regions where advanced anti-air defenses were limited. Some nations upgraded their fleets with modest avionics improvements or structural overhauls to prolong serviceability, ensuring the Corsair remained viable even as the technological gap between it and newer aircraft widened. Its ability to deliver precise strikes and endure harsh conditions meant that for many smaller air forces, the Corsair was not just a relic of the past, but a practical tool well into the Cold War era. Beyond active combat, the Corsair influenced post-war aircraft development indirectly. Designers studying its structural integrity and aerodynamic efficiency drew lessons that informed early jet fighters, particularly in balancing power, stability, and versatility for carrier operations. Its inverted gull wing, while primarily a solution for ground clearance and drag reduction, became a recognizable symbol of Vought's engineering approach, and a point of study for aerodynamicists seeking to optimize wing loading and landing gear geometry in high-performance aircraft. These contributions, though less visible than its combat record, reinforced the Corsair's role as a design milestone in the progression from propeller-driven to jet-powered aviation. Veteran pilots who flew the Corsair often remarked on how it prepared them for the challenges of transitioning into the jet age. The aircraft's torque-heavy takeoffs, abrupt stall characteristics, and complex carrier landing procedures demanded precision and confidence, qualities that became essential as pilots moved to faster, less forgiving jets. In this sense, the Corsair served not only as a combat asset, but also as a demanding trainer that shaped a generation of aviators. Its influence extended far beyond its final dogfights, leaving a legacy rooted in both the lessons it taught and the bridges it built between two transformative eras in aerial warfare. The conclusion of the F4U Corsair's operational life reflects its dual identity as both a product of its time and a design whose influence reached far beyond its primary era of service. By the mid-1950s, the Corsair had largely disappeared from frontline units in major powers, displaced by jet fighters that offered unmatched speed, altitude, and climb rates. Yet its legacy persisted, both through the nations that continued to operate it and the doctrines it helped to shape. The aircraft demonstrated that carrier-based fighters could rival, and even exceed, the performance of land-based contemporaries, redefining expectations for naval aviation, and proving that a single platform could fulfill multiple roles, air superiority, strike, and support, without compromising its core capabilities. These lessons became foundational for subsequent generations of carrier fighters, informing the design and deployment strategies of the early jet era. By the time the last Corsairs were retired from military service in the 1970s, they had served across 4 decades, fought in 2 major wars, and seen combat on multiple continents. Their longevity underscored the practicality of their design. Rugged construction, substantial range, and compatibility with a wide variety of missions kept them relevant even as newer aircraft entered service. For many smaller air forces, the Corsair offered a balance of affordability, reliability, and combat capability that made it irreplaceable until more modern replacements could be acquired. This long operational span cemented its reputation as one of the most adaptable and enduring military aircraft of the 20th century. Today, the Corsair exists primarily as a historical and cultural icon, preserved in museums, restoration programs, and airworthy examples displayed at air shows. Its distinctive inverted gull wing, powerful radial engine, and association with decisive campaigns in the Pacific and Korea make it instantly recognizable to aviation enthusiasts and historians. These surviving aircraft serve as reminders not only of its technological achievements, but also of the pivotal role it played in shifting the trajectory of naval air power during the most critical decades of the last century. Airworthy examples, often meticulously restored, continue to fly demonstrations that showcase the raw speed and presence that once made the Corsair feared in combat, connecting modern audiences with a formative chapter in aviation history. For aviation scholarship, the Corsair remains a benchmark for understanding how innovation, adaptability, and operational necessity intersected in mid-20th century aircraft design. Its success validated the integration of immense engine power, rugged structure, and multi-role capability as essential traits for carrier fighters, a philosophy that influenced the development of naval aircraft long after its retirement. Although eclipsed by jets in its final years, the F4U Corsair's career stands as proof that piston engine fighters, at their peak, could reach a level of versatility and performance that allowed them not only to dominate their era, but to leave a lasting imprint on the evolution of air combat. In this way, the Corsair's story is not simply about a fighter's rise and retirement, but about its role as a bridge between the propeller-driven titans of the Second World War and the jet-powered machines that would carry forward its legacy of speed, power, and adaptability.